Assalamualaikum. My name is Nurfazira binti Januar, and today I would like to present my PSM2 final report. My title is FPGA based digital control for BLDC motor. My supervisor is Dr. Afarul Razi bin Abu Bakar, and my two panels are Dr. Tur Muhammad Sumro and Dr. Wahyu Mulyo Utomo. This presentation consists of 5 different sections: introduction, literature review, methodology, result, conclusion, and future recommendation. For background of study, I discussed about 6 important key points. The first one are brushed DC motor that are widely used in application of simple and easy control system, and it is also low cost. However, it requires periodic maintenance and frequent replacement due to the brush and commutator construction. It also produces spark, which is the result of electrical noise. The BLDC motor, on the other hand, used for low, medium, and high power applications such as hybrid electric car and HVAC. Due to its brushless feature, it is more efficient, offers controllability, high durability, and produce noiseless operation. For voltage source inverter, it is used to drive BLDC motor, can change the phase of frequency or both according to the rotor position. It able to regulate the output voltage and frequency arbitrarily. Also reduce power consumption and improve its efficiency. There are 2 types of motor control feed method that are commonly used, which are hysteresis current control and PWM switching technique. For this project, we will be using PWM switching technique that the duty cycle control signal is added to the inverter switching signal to control VSI output voltage. PWM signal applied to upper and lower side of MOSFET switches that is going to be fed into BLDC motor. Next, analog versus digital controller. There are few disadvantages of analog controller, which are lack of flexibility, influenced by temperature and component aging. Digital controllers, on the other hand, offers upgradable and reprogrammable feature through software. It is also robust and can operate in high switching frequency. The choice of digital controllers that is going to be used in this project is FPGA, which are robust and customizable. It has high processing performance, flexible in implementing different algorithms using HDL to program motor control logic. Therefore, the study is conducted to implement FPGA controller to drive BLDC motor through 6-pulse converter and observing the performance in detail. In problem statement, I discussed about the disadvantage of conventional motor, which is low efficiency, require high maintenance, and produce electrical noise. To overcome this problem, I use BLDC motor that offers noiseless operation, has longer working life, and more efficient. Next, there are 2 types of inverter, which are current source inverter and voltage source inverter. For current source inverter, it requires reverse blocking diode, low efficiency, and produce high current harmonic. Therefore, I use voltage source inverter that are more efficient, has less voltage drop, provide clean current waveform since produce low harmonic current. It is also used for speed regulation in high power application. Next, for analog control, it is usually influenced by temperature variation, component aging, has higher cost, and lack of flexibility. Therefore, I use digital control, which is FPGA, that are flexible for changes to higher system alteration. It is also programmable according to the desired operation. There are 3 objectives for this project, which are to design 3-phase voltage source inverter to control BLDC motor. Next, to control the speed of BLDC motor using digital PWM controller using FPGA. Next is to program the HDL code using quarters 2 in generating PWM pulses for MOSFET switches. The scopes are designing a 3-phase inverter for BLDC motor using Altera DE170118 board, using digital PWM controller technique to control speed of BLDC motor. And the last one is programming FPGA to control the motor using quarters 2 software. Next, for literature review. Brushless DC motors are electronically commutated that are commonly comes in three different classifications, which are single-phase, two-phase, and three-phase. The common ones are single-phase and three-phase types of motor. The basic component of BLDC motor are permanent magnet rotor, which is this one, the north and south pole of the magnet, stator and rotor, and electronic circuit to control the phases of rotor winding. There are three types of rotor winding. The first one is surface mounted, this one, the embedded type, and the inserted type. Next, the BLDC motor operation is by attraction and repulsion between the magnetic poles. When the current flow in one of the three stator windings, it will cause a magnetic field to be generated and causing it to attract the opposite pole of the closest rotor winding. If the current flow to the adjacent winding, it will cause the rotor to move. Therefore, the rotor will follow this rotating field if each winding is charged sequentially. The working principle of analog is to work and process a continuous value within a certain interval of frequency. Advantage for analog control: it is inexpensive and robust. However, it is influenced by temperature and component aging. It is also has limited application. Digital control, on the other hand, involved in using intermediary binary language. It offers high flexibility and can perform complex computation. However, feedback signal resolution is limited, and finite word length will affect the accuracy of converted signal, and finally, time delays in control loop due to the computation of control algorithm by the processor. Next, it discusses about FPGA that requires VHDL program to be written in order to generate PWM signal. It offers high customizability, has high processing performance in terms of speed, and reusable every time a change was made. There are few types of FPGA available, which are Spartan 3E, Spartan 3AN, Spartan 6, Basis 2, and Altera DE17 that are going to be used in this project. Next, I discuss about inverter that converting DC to AC in order to drive the BLDC motor. It is a semiconductor-based device that converts DC to AC supply. Switching device used for inverter are BJT, MOSFET, IGBT, cross-commutated thyristor. There are two types of inverter, which are single-phase and three-phase inverter. For single-phase, there are two types of construction, which are half-bridge and full-bridge. Three-phase inverter, on the other hand, has 120 commutation type and 180-degree commutation type. Next, for methodology, these are the block diagram of the overall system for this project. First one is a DC source that is going to be fed into a three-phase inverter. In this inverter, we are using 6 MOSFET switches, and it will be used to drive BLDC motor that are connected in star connection. PWM signal will be generated by the written VHDL code in FPGA, and it will be fed into the gate driver that is used to boost the voltage output from FPGA, and it will produce a sufficient voltage to be fed into a three-phase inverter. Next, these are the construction of the three-phase inverter. We are using 6 MOSFET switches with a IRFZ44N. It offers fast switching speed and reliable device. It is also rugged and efficient. These are the capacitors that work as filter to reduce motor ripple current. We are using aluminum electrolytic type, and the rating are for 170 microfarad. And lastly, the BLDC motor, we are using MW16C high power motor from Golden Motor Technology. It is designed for electric motorcycles or scooter. It has high efficiency and reliability. It also offers noiseless operation and greater dynamic response, and has longer operating life. Next, the function of gate driver is to boost the voltage for three-phase inverters input voltage rating accordingly. The model we are using is SI8239X. It provides robust isolated data path, has longer service life, high reliability, low power consumption, and better immunity to noise noise and magnetic field. So these are the circuit design that used to develop switching pulses on quarters 2 software. This circuit will then be transferred into FPGA board to generate appropriate PWM signal. So the first design of this overall circuit must start with clock divider block. The input clock of this circuit is 25 MHz and it is going to be divided into these several frequencies. We are going to use 1 kHz that is going to be fed into D-type flip-flop to divide the frequency into half. So these are the output obtained from the block. Moving on to the LPM counter block, we have set the counter for each pulse to 10 counter with the input clock frequency of 500 Hz that is obtained from this block earlier. So for one cycle, we have 60 counter that are counting from 0 to 59. This counter will produce 8.33 Hz switching frequency with the period of 120 milliseconds. Next, each block consists of VHDL code that is written to generate PWM signal according to the switching pulse design. 150-degree conduction mode is used to program the logic control of the BLDC motor, with the difference of each pulses is at 30 degrees. Since we are using 6 MOSFET switches, so we have to have 6 PWM blocks. After the simulation on quarters 2 has been successfully simulated, we can assemble the overall system according to this connection. The motor will move accordingly to the PWM signal designed earlier from the quarters 2 software. The result and discussion. These are the simulation done using MATLAB in controlling the different speed of BLDC motor. We are using 500 DC voltage with 6 MOSFET module, 20 ampere with the rated speed of 3000 RPM. So these are the switching pulses obtained from the simulation. Next, moving on to the result obtained for the hardware implementation of this project. The first one is we test the gate driver. This test is conducted to ensure that the gate driver is functioning well and is able to boost the voltage for the inverter. We are using 10 kHz function generator and 10 volt used as the input voltage for the gate driver, and from the oscilloscope we can see that the gate driver is able to boost the voltage. So we can say that the gate driver is in good condition. Next is the switching pulse result. These are the results obtained from the simulation. Switch 1 will on from 0 to 29. So here we can see that it is on from 0 to 29, and switch 2 will on from 10 to 39. Switch 3 will on from 20 to 49. Switch 4 will on at 30 to 59, and switch 5 will on from 0 to 9 and 4 to 59. Switch 6, it will on from 0 to 19 and 50 to 59. Next, we test the PWM switching pulse onto the hardware implementation, and we can see that the result obtained from simulation match the hardware implementation result. This is the switching pulse for S1, S2, S3 and S4. These are the switching pulse for S3, S4, S5 and S6. From the oscilloscope, we are able to measure the peak voltage of 4 volt with the period of 120 milliseconds and the frequency of 4.33. So it is safe to say that the hardware implementation result met the PWM switching pulse design on the simulation. Next, after all the testing done and the result obtained are verified, we can proceed to assembling the BLDC motor to the main circuit. Here we can see that the switching pulse design able to drive the BLDC motor. So these are the face-to-face voltage of BLDC motor. The yellow one is for red and yellow. The blue one is for yellow and blue, and the pink one is for blue and red. So for the conclusion, we can say that the inverter design able to drive the BLDC motor with the appropriate PWM signal obtained from the VHDL code written using Quartus-2 software. And finally, this project can be concluded as the effectiveness of the three-phase VSI to drive the BLDC motor is well verified from the result obtained. The VHDL program written using Quartus-2 software has proven able to generate appropriate switching pulse for the BLDC motor control scheme. This proposed FPGA-based digital controller is simple yet an effective solution for BLDC motor drive digital control. PWM technique used to drive BLDC motor helps in reducing the complexity of motor control hardware and has lower cost. And finally, 150-degree conduction mode topology produce simpler hardware construction, economical and easy to implement. And finally, for the future recommendation, it is recommended to construct systems that are able to perform different speed control of BLDC motor using digital controller. Next, it is advisable to thoroughly check the continuity of each MOSFET switches leg to avoid any short circuit between the switches to avoid distorted output waveform that will cause the motor not running smoothly. Next, use heat sink for each MOSFET switches to dissipate away heat produced from the component. And finally, it is recommended to construct a comparative study to further comprehend the difference between the available conduction mode. So that's all from me. Thank you.